This is lesson 4 in the GCSE Waves Part 1 topic, entitled Measuring the Speed of Water Waves. And by the end of the lesson you should be able to recall an experiment which allows you to calculate the speed of water waves. You should be able to use data from simulations or otherwise allied to the wave equation to determine the speed of water waves. The experiment I'm going to talk you through now is a required practical, and therefore it must be in your notes. So could you put a title there, and can you make a sketch of the apparatus here, or if you're printing stuff out at home then by all means do that. Pause the video now whilst you do that. Okay, so how do you use that apparatus to determine the speed of water waves? Well, first of all we need to create those water waves. And the water waves are created by a piece of equipment called a signal generator, which produces vibrating electricity, which is fed to a motor which sits on a piece of wood. And when the motor receives the pulses of electricity, it causes the wood to vibrate, and we generate water waves in our ripple tank here. The frequency of those water waves is the same as what is on the signal generator. Now you can find out what that frequency is just simply by reading the display on there. So we know the frequency of the water waves because it tells us on the signal generator. Once we've produced our waves, we can then observe those waves on a screen underneath the ripple tank itself. Light comes from the lamp here, it shines through the water onto the screen. Where there are peaks, there is more water for the light to pass through, so you get dark patches. Where there are troughs, the light can pass through more easily because there's less water, and you get light patches. So you get a series of moving light and dark patches down here. Now you should remember that a wavelength is the distance between two consecutive peaks or two consecutive troughs. So it's the distance between two light parts or two dark parts. Now with this moving it's very difficult to see, so what we normally do is we take a photograph. When we take our photograph, we make sure the ruler is in view of our picture. That way we can then measure the distance between two dark patches or two light patches. We will then use the wave equation, wave speed equals frequency times wavelength, to calculate the speed. Okay, so what might the results look like then? So again, this needs to be in your notes. You may see something like this on the screen below the ripple tank. So here are our dark patches, which are indicated by these lines here, and they are our peaks, and the light patches are our troughs. Now if you remember, the wavelength is the distance between two peaks. We've got 1, 2, 3, 4, 5 peaks there, so there are 1, 2, 3, 4 wavelengths. So if we know the distance in this case for 4 wavelengths, 40 centimeters, we can work out what one wavelength is. 40 divided by 4 to give us 10 centimeters. So we now know the wavelength. The frequency, we're being told, is 12 Hertz. That's what the reading is on that signal generator. So to work out the wave speed, it's frequency 12 times wavelength 10, and we end up with an answer of 120 centimeters per second. If we'd have measured the distance in meters here, then our answer would have come out in meters per second. Pause the video whilst you get that down into your notes. Okay, the last thing I'd like you to put into your notes today, under the title Wave Simulations, I'd like you to make a copy of this table here. Could you pause the video now and do that? Okay, now to access the website that we're going to use today, you can either Google PHET, P-H-E-T, Waves Intro, or follow the direct link here. If you've chosen to Google PHET Waves Intro, then it's the top result that you need. So if you click on that, click on the play in the animation there, and it'll start to load the simulation. Okay, there are 3 simulations. We're just going to be looking at the water waves today, so if you go ahead and click on that. Okay, you'll be then presented with this view. Now I think it works better if you look at the side view of this. So if you do that, it turns it round, so we've got our tank here and we've got water dripping into it. The next thing I'd like to do is to take the frequency down here and put it down to around about the second one, like so. Amplitude is nice and high, you can leave that there. If we now press play, we should see some drops coming out the tap. If I open the tap there you go. So drops come out the tap, and as they come in repeatedly they generate waves. Now your first job is to determine the time period of the wave. Now that's easy, that's just simply the time it takes to make one complete wave. And as these waves are being made by drops falling into the water there, all we need to do is to time how long it takes to make one drop. So I'm going to drag my stop clock across here, just so that it's nice and close like that. And when I see a drop coming out, I'm going to start my stop clock. I'm going to stop it as soon as I see the second drop. That'll give me the time between drops, or the time period of the waves. So when we're ready, there we go, and stop. Okay, I was a little bit quick on that one, but 2.3 seconds. Now, in your table, you're going to record that time of 2.3 seconds, or 2.36 seconds, I should say, there, 2.36 into your table. Okay, so that's our time period. To work out the frequency, if you remember from a couple of lessons back, the frequency is 1 divided by the time period. So 1 divided by 2.36 is 0.424 if you round it up. Okay, the next thing we're going to do is measure the wavelength of the waves. Now to do that we need two things. We need to click on the graph bit here. Okay, so we can now see the familiar wave pattern, and we're going to use the tape measure, which is down here. Okay, now all you have to do is pause the waves, pressing the pause button here, take your tape measure, take it to a peak, and it's this little bit here of the tape measure is the 0, so I'm not quite on that. I'm on that peak around about there. Stretch it out to the next peak, making sure it's horizontal, and there I've got 4.1 centimeters. So my wavelength, the distance between two peaks, is 4.1 centimeters. Pop that into my table. And finally, all we need to do now is to work out the wave speed. And the wave speed, remember, is frequency multiplied by wavelength. So it's 0.424 multiplied by 4.1, which gives us 1.74 centimeters per second. Centimeters per second because we measured the wavelength in centimeters. Okay, so when you've done that, what you're going to do is you are going to alter the frequency. So we're going to take it to about the halfway mark. We can leave the amplitude and everything else the same. Reset our stop clock, and you're simply going to repeat the process for this new frequency. So you're going to start the waves off again, like this, and you are going to measure the frequency, the time between splashes, as it were, the time between the dots being produced. Now, you can see I had it easy, I did it really nice and slow. You're going to have to be pretty quick to do this. So, okay, so that's a rough indication, but I'll leave you to do that. So you're going to do exactly the same thing, but for two different frequencies. Okay, so you should have a table with 3 different results in. Now, it's tricky to do this, but you should find that the wave speed remains the same. The frequency and wavelength will change, but the wave speed in the water should remain the same. Okay, so hopefully by now you should be able to describe an experiment in the laboratory that can be used to measure the speed of water waves, and you should be able to use the wave equation to calculate wave speeds using experimental data.